Let me show you how you can turn on hypervisor so that you can run these softwares like Oracle, VirtualBox and VMware. So this is the memory, and if I toggle it, here is the name, which is dbcluster01. Let's see if we actually solved the mail server. We haven't. So let's restart this. Now it's in running state. Hello everyone, my name is Shubham and I'm back with a very amazing chapter which is virtualization basics. So before any further ado, let's go into this room. But if you want to know what we have done previously, these are some of the rooms that we have completed. And if you are following this playlist, you can see our previous videos that we have done so far. So, without wasting any of your time, let's get into this room. So, this is a premium room. Make sure you have the premium subscription, and if you don't have that, just open your notes and start taking good notes. But if you have, then you have to follow. You can follow along me. You don't have to, but you can follow along with me. Let me join this room and let's start with the introduction. Let me amp up the text so that you can see it clearly. In the previous rooms, you learned what the components of a computer are and how they communicate with each other. In this room, you will learn how companies have optimized their computer components to reduce costs and build flexible, scalable systems that power the modern internet through a concept known as virtualization. Have you ever considered how expensive and inefficient it would be if every piece of software or every website required its own physical server? Virtualization was created to solve exactly this problem. So, your manager asked for help on improving the hardware utilization of a computer that hosts a website. Let's explore the concept of virtualization and help your manager. Learning objectives. Understand why managing applications on individual physical servers is inefficient. Learn how virtualization addresses hardware utilization and stability challenges. Understand the component of a lab machine. Learn how containers have further optimized hardware utilization for applications. Prerequisites. Inside a computer system, why it is coming soon? Maybe they haven't updated their room. Computer types, client server basics. We have we have covered these three rooms. So we are ready to challenge ourselves to learn about virtualization. And if you want to learn about these things, our previous three videos are based on these three things. So if you haven't seen these videos, you have to watch them first so that you can understand this room easily. But I don't think that these are interrelated with each other. This is an individual topic on its own, I think. So let's go with it. Task 2, Virtualization Overview. Before the concept of virtualization, the rule of thumb in IT was one server is equal to one application. In the early days, digital services were run on physical machines, and each machine typically had a single clear purpose, such as hosting a website or storing data. As businesses added more services, they naturally increased the number of physical servers, and the one job per box approach became the standard for building reliable systems. This meant that if a company wanted to run a website, a database, a email service, and an internal app, they would need separate physical servers for each one. The problems were obvious. So, what are these problems? High cost. Buying multiple physical servers is expensive. Not just the hardware, but also electricity, cooling, maintenance, and data center space. Low utilization. Most applications don't use the server's full capacity. Many servers stayed at 5 to 20% usage, wasting CPU memory and storage resources. Slow deployment. Setting up new physical servers could take days or weeks. Hard to scale. If an application suddenly needed more resources, you often had to buy yet another server. That will not be a good idea. In short, companies were paying a lot of hardware that was not being fully utilized. The need for sharing hardware safety and efficiency. Virtualization introduced a new idea. What if multiple applications could share the same physical server safely? A virtualization layer called a hypervisor was introduced to act as a referee between lab machines and allow each virtual computer to behave independently like a physical computer. The building analogy. Imagine if a single person lives alone in an entire 10-floor building. The person uses only one floor but must maintain the entire building. What that person have to maintain is electricity, cleaning, water, and security of all the 10 floors. Most of the building stays empty and wasted. It's expensive, inefficient, and unnecessary for his needs. Now imagine dividing the building into separate apartments. Each apartment has its own door, walls, kitchen, and privacy. Different people can live independently without bothering each other. They all share the building's main structure, electricity, water, and elevators, making it cheaper and more efficient for everyone. Okay, so this is the previous scenario, and after the virtual machines, and you can relate these separate yellow parts as a machine. This is virtualization. The building is equal to the physical server, the apartments is equal to lab machines, the tenant is equal to applications and operating systems, the building manager is equal to the hypervisor. So you can relate these terms with these things here you can see. And this is also a very nice example of explaining the hypervisor, that is virtualization software. Each virtual computer known as a lab machine, that is VM, and also called as virtual machine, act as a independent system with the own operating system, apps and settings, even though they all share the same physical hardware underneath. मैं आपको एक बहुत ही सिंपल एग्जांपल देता हूँ थ्रू ट्राई प्लेटफॉर्म. अगर हम ट्राई को ही कंसिडर करते हैं कि वो एक फिजिकल सर्वर है, तो जैसे कि मैं इस रूम को अभी देख पा रहा हूँ, और प्रीवियस टास्क में हमने क्या किया था, हमने एक वर्चुअल मशीन को ओपन किया था जो कि यहाँ पर एक पूरा का पूरा एक कंप्यूटर एक क्लाउड के ऊपर वर्क कर रहा था, जहाँ पे मैंने आपको एक वेबसाइट ओपन करके दिखाई थी इन प्रीवियस रूम. सो मैं अगर उसी सेम रूम को कर रहा हूँ, तो कोई और भी मेरी तरह उसी सेम रूम को कर रहा होगा, मतलब वो भी उस रूम से कुछ ना कुछ पढ़ रहा होगा. तो ये कैसे वर्क कर रहा है? मान लीजिए कि इस बिल्डिंग के अंदर, कहाँ गई वो बिल्डिंग? दिस बिल्डिंग, इसके अंदर मान लीजिए मैं ये फर्स्ट बॉक्स के अंदर ऑपरेट कर रहा था वो वर्चुअल मशीन को. अब कोई और भी है, मतलब बहुत सारे लोग हैं जो कि सेम मशीन को लर्न कर रहे होंगे, जैसे कि मैं अभी उस मशीन को लर्न कर रहा था. तो वो मेरे सेशन के अंदर नहीं इंटरफेयर कर सकते. उनका एक अलग सेशन बनेगा। तो आप उस सेशन को, उस मशीन को, उस वर्चुअल मशीन को आप कंसीडर कर सकते हैं कि वो दूसरे अपार्टमेंट में सारा सारा चीज़ें जो हैं वो वर्क कर रही है। तो मेरा अपार्टमेंट सेपरेट है और ये जो जो भी वो बंदा होगा, जो भी वो पर्सन है, उसका अपार्टमेंट अलग है, जो कि वो अपने टास्क यहाँ परफ़ॉर्म कर रहा है, मैं यहाँ पर परफ़ॉर्म कर रहा हूँ। So this is what we can see and compare with the virtualization. Now let's answer the questions. What does virtualization enable multiple applications to share? That is the underneath uh, physical server, maybe physical server, physical server. No, operating system. No, virtual machine. Enable multiple application to share. What does virtualization enables multiple applications to share? That is the space under it. So what that space called? Physical server. Physical server. What is it? Physical server. I'm offline. Come on. That will be correct answer. What is the name of the software that manages the resources for each lab machine? Hypervisor? Yes. Now let's go to the task 3. Hypervisor, the building manager. A hypervisor is the core technology behind virtualization. It's the software that creates and manages lab machines. It is a special piece of software that divides a physical computer into multiple virtual ones, gives each lab machine its own share of CPU, memory, and storage, keeps everything isolated and safe, manages the life cycle of lab machines, start, stop, pause, clone, delete. Hypervisors have two main type of implementation, each of which is used for specific scenarios. From home labs to large data centers, Type 1 hypervisors run differently on the physical hardware, making them fast, efficient, and idle for servers and professional environments. Type 2 hypervisors run within a existing operating system, making them easier to install and idle for learning, testing, and small setups. Below a table showing which use case is best suited for each hypervisor type. The use cases can run on both hypervisor types, but it's not the best approach, giving the main objective of each. Now, use case and the type of the hypervisor. Test malicious files. You can test the malicious files on the second one. Because if something went wrong, you can delete that hypervisor, not hypervisor, you can delete that virtual machine. Production server, that is type 1. Database server, type 1. Software testing, type 2. Kali Linux, type 2. Data center, type 1. You can see these are the testing things. So testing malicious files, software testing, a, a hacking operating system which is Kali Linux, where you can perform some dangerous tasks, or you can analyze malware. So that all things go in type 2, which is A hypervisor runs within an existing operating system. So here you can see this is the VMware Workstation Pro. So if I click on this thing, this is called the, you can consider it as, you can consider it as hypervisor, but it's not hypervisor, it's virtual, uh, it's a virtualization software where you can run different operating systems. So here you can see I installed Kali Linux, which is I can power on this thing. The memory I gave to this virtual machine is 6 GB, processors 8, hard disk 80 GB. What network it's using? It's NAT network, USB. So it is a operating system inside a operating system. So I can run this operating system inside a operating system, that is my Windows operating system. So I can run Kali Linux in Windows using this. Or usually what I do is I use the kex, which is WSL. So that uses the Tiger VNC, which is also a virtualization software. So this is how you can do that. If you want me to create a video on that how we can run Kali Linux in your Windows, I can show you that if you comment me that under this video. When using virtualization to test malicious files, care should be taken to ensure that the host machine does not become infected by the malware being tested in the guest machine. One approach is to use different operating systems for the guest and host machines, or to isolate the guest machine so that it does not communicate with the host. As I told you previously, if you want to test any malware, which is a harmful program, if you run it on your host machine, which is in my case, it's Windows machine, it will infect the host. But if you run that malicious software or malware inside a virtual machine, anything, any disruption that is done by the malware, you can delete that machine and reinstall the machine. In that way, you can play. You have to play all these things safely because malwares infect your systems at kernel level, and they also infect your uh, DLL files or maybe boot sectors, which is very, very difficult to remove the virus from these locations. So if you go through the Security Plus, which is CompTIA Security Plus course, you come across these terminologies like macros and all kind of DLL viruses, which is very devastating for your computer. Lab machines, the apartments. A lab machine is a virtual computer created by the hypervisor. Even though it's virtual, it behaves as a real machine. It has its own virtual CPU, RAM, storage, and network. It can run any operating system, Windows, Linux, etc. It's completely isolated from other virtual machines. This means that if one VM breaks, the other continue to work. As I showed you earlier, this is a virtual machine, and inside it I have installed a operating system which is Kali Linux, and it has its own memory, processors, hard disk, network, and all these things. You can also see username and password. Kali Kali. Okay, so I hope you understand that you can deploy VMs on your own computer using tools such as Oracle, VirtualBox, and VMware Workstation. This is what I am used to use. This is called VMware Workstation Pro. Here you can see. You can install it on your computer if you want to install Kali Linux. This type of software acts as a type 2 hypervisor and lets you run multiple operating systems such as Windows, Linux, and Mac OS. Since you have learned what a hypervisor and VM are, let's take some examples where you might need them. You need to work on a different OS like Kali Linux, but you can't buy another whole system. So you installed a hypervisor and run a Kali Linux VM on it. You want to test whether a file is malicious, so you set up an isolated lab machine to protect your main computer from being infected. This is also that I explained earlier. Let me show you how you can turn on hypervisor so that you can run these softwares like Oracle, VirtualBox, and VMware. So if you press window and start typing what it is, software, my mind get blank just now. Turn, yes, turn Windows features on and off. If you go there and you have to find this Windows hypervisor platform and click it, you have to check it so that it shows that box checked, and after this you can install these virtualization softwares. Okay, I hope you understand this. So that is a crucial step in order to run your virtual machine inside a Windows host. Now containers, the rooms inside the apartment. A container is a lightweight isolated environment that runs a single application and all the necessary components to support it. Instead of bringing a whole separate operating system, a container borrows the core of the existing system by running on the kernel, which is the part of an operating system that communicates with the hardware and manages resources such as memory and running programs. Because containers share this kernel, they start quickly and use fewer resources than full lab machines. But it also means that must match the host system's type. For example, you can't run a Windows container on a Linux machine. And that was self-explanatory. Explanatory. Maybe I'm pronouncing it right. Containers behave like small self-contained spaces because they package the application and its dependencies, that is libraries, tools, versions. They share the host's operating system, so they start almost instantly. They remain isolated from each other, so a misbehaving container does not affect the other. They can run consistently on any machine, making them perfect for developing, testing, and scalable deployments. The easiest way to deploy a container in a VM is using Docker. So Dockers are also very important to understand. Docker is an open source software platform that simplifies the process of building, deploying, and running applications using containerization. The image below illustrates the relationship between hypervisors, VMs, and containers. So maybe you would like to take a screenshot of this thing because it's important. So we have a physical server. Consider it as a Windows host where we are running hypervisor. And inside that hypervisor, we have two machines, which is virtual machines. You can think it. The first one is the Windows virtual machine, The second one is Kali Linux virtual machine. And the second one have containers, container A and container B. If the virtual machine B is a Kali Linux machine, the container should be a Kali Linux because as discussed earlier, you cannot run a Windows container on a Linux machine. So it has to be a Windows container. And if you are using Linux, then these containers must be a Linux container. In summary, VMs provide the full apartment with maximum separation and flexibility, while containers offer lightweight rooms, ideal for scalable, fast deploying applications. Now let's answer the questions. Suppose a user wants to deploy a study lab on their machine to practice some exercise for a cybersecurity certification. Which type of hypervisor will they use? That will be type 2 because in practice it is also considered as testing. And if someone is practicing for cybersecurities, they 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 will be end up using a malware. So that will be done in type 2 hypervisors. Yes. Suppose a company wants to host multiple small applications in the same lab machine, and what should they use? Hypervisor? No. Why it is? Why it? Oh, that will be container. Containers. Yes. Now let's go to task 4. Managing virtual machines. After learning about virtualization, you were hired. Oh, we are hired. So you were hired to be responsible for the virtual environment for Autogallo, 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 a company that has recently started using lab machines. In this company, they use an application called Virtualization Manager. The application provides a clear view of the overall status of an entire virtualization environment, providing details of each virtualized instance and the physical hosts. It also enables you to run actions and manage the VMs you create. Your manager has your manager has asked you to investigate an issue with the email service. Essentially, everyone in the company stopped receiving emails today, and no one knows what happened. So we are in trouble. Open the Virtualization Manager's site by clicking the View Site button below, and let's investigate. So let me click on this button. Analyze lab machine states. Okay, so I have to zoom out a little bit, but you are not gonna see it clearly then. That will be good, I think. In the home screen, you should see three main sections. Summary provides a generic view of the state of the environment. Lab machines provide details of each VM and enables you to run actions on them. Hosts displays usage and performance details for each physical server. Go to the lab machines section and look for the VM with the name mail server. So let's go to that location. VMs, no, I am not able to click on this. Index post all states. We have to go to the lab machines And where are those lab machines? Oh, this is where the lab machines are. And here is the problem. And this is the mail server. So what we have to do after that? We are here, mail server. Looks like this lab machine has entered an error state. Let's try rerunning this VM using the blue square button to restart it. And this is the button that we have to press. Yes. So now it's in running state. Okay, what we have to do next? After running again, it appears to be working correctly with no errors. Yes, it's running. Creating a new lab machine. As part of your routine, you create lab machines for other teams. After resolving the email server issue, you received a task to create a VM to support the marketing team's website. Okay, so now we have a new task. Now let's create a VM to host their marketing website. In the lab machines section, locate the create VM button on the top right of the lab machines section and click on it. So this is where we found our button. Now let's go to, oh, we can zoom it. That's nice. Now you can see it properly. Let me exit out of that here. So where we have to go is create virtual machine. Okay, so you should fill out the form with how much hardware your lab machine will be using. The name of that machine will be marketing VM. So let me copy and paste it for 800. Okay, so this will be 4, this will be 8 and 100 gigs. Now create this machine. And what is the name of that machine is marketing VM. Okay. Now at the top of the list of lab machines, you should see your created VM. That is this. Analyzing hardware usage. Another routine task you have is to manage the health of the physical servers and report status to your manager. Go to the host section at the bottom of the page. So where we have to go here. So we are here. Okay. By analyzing it, we can identify HP prod 01 has the capacity to host more VMs. HP prod 02 is almost operating at 100% of its capacity. And we might need to report this. HV backup 01 is disconnected and does not host any VMs. So this is the thing. This is working perfectly. This is what we can say it overloaded and this is disconnected. So let's see what's our next steps. Now answer the following task questions to conclude your shift as the responsible for virtualization in Auto Gallo. What is the name of the lab machine that has been running for the longest time? Okay, let's see that. Longest time. So uptime. We can yes, we can use this to toggle that, which is a mail server, which is running from 3 hours. No, 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 no. Here we can see 3 weeks. So uptime, if we click it again, you can see, let me zoom out once more, monitoring system. This has the highest uptime. Yeah. What is the name of the lab machine that is using the biggest amount of memory? Memory. So this is the memory, and if I toggle it, here is the name, which is DB cluster 01. Let me copy the name of this machine and paste it here. How many VMs are in the running state after you solved the issue on mail server? Let's see if we actually solved the mail server. We haven't. So let's restart this. Now it's in running state. And now I forgot the question. How many VMs are in the running state after you solve the issue on mail server? Running state. How we can conclude that? Okay, by status. So 1, 2, 3, 4, 5, 6, 7, 8. 8 machines are in running states right now. What is the name of the physical machine that is hosting most of the VMs? सबसे ज़्यादा VMs कहाँ होस्ट हो रही है? What is the name of the physical machine that is hosting most of the VMs? Most of the VMs. How am I supposed to know that? Oh, we can also sort from here. This one, maybe? Oh, yeah. Yes. This one. VMs. Here is 3 VMs. Here is 8 and 0. So HP prod 02. This is, I think, should go here. And that's the correct answer. Now, last task conclusion. In this room, you learn why virtualization is such a critical foundation in modern IT. Both the maximizing hardware efficiency and the safely isolated environments. Key terminology. Let's quickly review some concepts we learned in the room. Virtualization enables a single physical computer to act like multiple separate computers. Hypervisor, the manager, software that makes and runs the virtual computers. Lab machines, a whole virtual computer inside the real one with its own system. Containers, a small isolated box for one app that shares the same system as the host. Container images, a pre-packed recipe template used to create containers. Network ports, special numbered entry points that apps can use to talk over the network. We also concluded that the key benefits of virtualizations are cost saving, better resource usage, safe testing for cybersecurity, fast deployment, flexibility, portability, scalability, centralized management. Further learning through hands on practice, you experienced how virtualization specifies and accelerate applications deployment, providing a fast and secure way to run applications consistently. With these fundamentals, you are ready to explore the cloud concept in the Cloud Computing Fundamentals room, which uses virtualization, containerization, and automation to provide scalable on demand services. So, I hope in this room you will learn something different, and these and these rooms are newly added to the pre-security pathway. So this is also new for me, but because I have done some of the things to run my machines like Kali Linux or Windows machine in my VMware Workstation Pro, so I knew some of the things, but most of the things are also new for me, and I hope you learned uh, by this video a lot. And make sure to boot your Kali Linux machine. So let me tell you how you can do that. What you have to do is just go to the Kali Linux website, like get Kali, and here just go to this section, virtual machines, click on it, and as you can see, this is what I am using right now. It's reliable, and I like the VMware over VirtualBox. I don't know why, but I like this thing. Just click on this file here, 3.6 gigs of the image that you can download for this software, and open it. And you also don't have to open it. You usually get a icon where you have to press uh, double click on that image, and it will automatically open in the VMware workstation, and you will be able to run your own Kali Linux machine inside your Windows host machine. I hope you are going to do that, because we are going to use Kali Linux machine in our upcoming lessons. So let me check the button and mark this box done. And, and you and if you have any questions about this room and any other questions that you have, you can comment inside, not inside, under this video in the comment section, and I will happy to help you, and I will happy to answer all your questions in there. And I'm also going to spin up my Discord server very soon, and I will tell you when I'm going to do that. I hope you like this video, and we are going to meet in our next video, which will be cloud computing fundamentals. So you have to wait for that, and make sure to learn all the previous rooms before going to cloud computing fundamentals. And bye bye, stay safe.